Welcome to Math with Professor V. Here's your latest series of the day, and this is a special bonus video because I'm actually going to be solving two infinite series in the video. So the first one we're just going to determine whether it converges or diverges, is the sum n equals 1 to infinity of cosine of 5 to the n over n factorial. Go ahead, pause the video if you'd like to try it on your own. I'll walk you through my thought process. So even though there's a factorial, ratio test is not going to be helpful because we have cosine of 5 to the n over n factorial. So doing ratio test is just going to make it a mess. Then you start thinking through maybe your other options. No, we're not going to do integral test. No, we're not going to do root test. And then think back to one of the first few tests that you learned, namely the test for divergence. And the test for divergence tells us that if the terms don't approach 0, so let me remind you, test for divergence, if the limit as n approaches infinity of an does not equal 0, then we know that the sum n equals 1 to infinity of an diverges. So if I can somehow show that these terms don't go to 0, which I already kind of have a feeling like they're not, right? I do know factorial grows faster than 5 to the n. I'll show you why in just a moment. So we can show that these terms inside here, the argument of cosine goes to 0, and cosine of 0 is 1. So I'm feeling like this is a very strong approach. This is where things are going to go. So now the task that remains ahead of us is to show that 5 to the n over n factorial approaches 0. How do we do that? There's a couple different ways. I'm going to do the most common way, okay? So down here, let's consider 5 to the n over n factorial. Now, 5 to the n means you have 5 multiplied by itself n many times. I'm going to list it out in a strategic way. So 5 times 5 times 5. And then I'll just put dot, 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 dot. And then you've got a couple more at the end. And then let me be specific. I didn't just randomly write 5 a bunch of times. This is n many times. Then we have n factorial in the denominator. That's the product of 1, 2, 3, 4, 5, 6, 7, all the way up to n. So I'll write n minus 1 and then times n. That's the last one. Notice we have n factors in the top. We have 5 n many times, and then I have n factors in the denominator. And I want to group them. I want to group them in a strategic way. I want you to observe something to the right of the pink line that I just drew. If I group these terms together, 5 over 6, that's less than 1. 5 over 7, that's less than 1. All of the rest of the pairings are going to be less than 1. Can you see that? Good. Now to the left of the pink line, these 5's cancel. And then all of these terms I'm going to keep with me. Okay? All of these terms I'm just going to keep with me, as well as 5 over n. But I can now say, with confidence and accuracy, that this entire product here is less than or equal to 5 to the 4th over 1 times 2 times 3 times 4 is 24 times 5 over n. I'll repeat that. Since all of the circled pink pairings, all of those factors are less than 1, I can say this entire product is going to be less than or equal to everybody not circled in pink. 1, 2, 3, 4 powers of 5. This one canceled. 1 times 2 times 3 times 4, that's 24, as well as 5 over n. 5 over n. Everything here is less than 1, so I can say this is less than or equal to all the rest. Why is this important? Because then now I can say, well, if I look at the limit as n approaches infinity, 5 to the 4th over 24 times 5 over n, these are all just constants, and n is getting very, very large. This limit is going to be 0. And since I just showed that the terms that are inside, that are part of the argument of cosine for our series, 5 to the n over n factorial, are smaller than this expression, then this implies that the limit as n approaches infinity of 5 to the n over n factorial is 0 also. by comparison, basically, but it's not comparison test. I'm just working with the terms here. I'm not working with the series, okay? Another option for proving that this limit is 0 is you could use the ratio test for sequences. Now, the ratio test for sequences is not commonly taught. It's not even mentioned in most textbooks, but it is really nice. I have a whole separate video on it, so if you do want to go give it a try, just make sure with your instructor before you put it on the test that they're okay with you using that technique, because like I said, it's not in every book. So now back to the problem at hand. So we're looking at the limit as n approaches infinity of cosine of 5 to the n over n factorial. Now, most of the time we take this limit, since it involves a composition of functions, and we just kind of pass the limit inside mentally. I'm going to write it out nice and neat. This is cosine of the limit as n approaches infinity, 5 to the n over n factorial. We just showed this goes to 0. So then I'm left with cosine of 0, which is 1, and not 0. So since the limit as n approaches infinity of cosine 5 to the n over n factorial equals 1 and not 0, by the test for divergence, I let my students abbreviate TFD. But if your professor doesn't let you, write it out. We know the sum, n equals 1 to infinity, of cosine 5 to the n over n factorial diverges. Okay, good. That's it. If you had been asked whether or not this series converges absolutely or conditionally, it wouldn't make a difference, because when the series diverges and you use test for divergence, then that's the answer to the problem regardless. If you can just jump straight to that when you notice it. It's not an alternating series. If you want to recap on absolute versus conditional convergence, I have a whole separate video, so it's linked in the description. That's the first one. How was that? Okay, one more. And it also involves cosine. This is by request from a viewer. So we have the sum n equals 1 to infinity, 2 plus cosine of n over n. So if you want to give the video another pause, try this on your own. Here's how to begin. I know cosine of n is bounded, right, between 1 and negative 1. That's true always for cosine and for sine. And let me see if I can make this part, this middle part of the inequality, match the numerator that I have here. So in order to do that, I need to add 2 throughout, right? Okay, so now I have negative 1 plus 2, that's positive 1, is less than or equal to 2 plus cosine n is less than or equal to 3. And so I'm just going to focus now on the lower two parts here of this inequality. 1 is less than or equal to 2 plus cosine of n, which also means 1 divided by n is going to be less than or equal to 2 plus cosine n divided by n. We know n is never negative because n is going from 1 to infinity, so we're fine. Well, who is 1 over n? We know that term. It's a very familiar. It's the terms of our harmonic series. So we know the sum n equals 1 to infinity of 1 over n. That's our harmonic series. What does the harmonic series do? It diverges. That's a known fact. You can just state it. Make sure you actually write out a sigma when you refer to the harmonic series. 1 over n is just a sequence. You need to write the sigma if you're talking about harmonic series, and it has to start at 1. It doesn't start at 0. Be careful. Well, since the harmonic series diverges, and right here I have the terms of our series, 2 plus cosine n over n, and I've just shown that they're larger than the terms of another divergent series, then this tells me the sum, n equals 1 to infinity, 2 plus cosine n over n, also diverges by comparison, by direct comparison. You don't have to write the word direct, but I'll throw it in there. We didn't do limit comparison, we did direct comparison test, okay? So that one was a lot easier, more straightforward. Hopefully you got it right. I did want to mention something I forgot to say earlier. Please forgive me. This inequality that we wrote out, this is only true if n is greater than 5. But that's not difficult to satisfy because remember, we're taking the limit as n goes to infinity. But we should be precise and mention that. So do forgive me for not saying it earlier. Anyways, I hope you enjoyed this video. Give it a thumbs up, subscribe if you haven't already. And like I said, if you're interested in how to show that the limit of 5 to the n over n factorial is 0 using the ratio test for sequences instead, I have the video linked in the description. It's pretty lovely. So that's it. If you need any other help with infinite series or sequences, then check out the rest of the videos on my YouTube channel. They're all under the Calculus 2 video lectures playlist. I got everything for you. Power series made easy, Taylor-Maclaurin series. You should be good to go. And don't be afraid of sequences and series. They're super fun. You just need it broken down in a really clear way, which is what I'm here for. Also follow me on Instagram, TikTok, Twitter, Math with Professor V. Thank you guys so much for your support. I love you all. I'll be back soon. Bye.